Okay, this part we will discuss for the KMK 20/21 set 1. So the first question, draw and name the molecular shape. So the compound given is IF3, IF4 plus and IF4 minus. So molecular shape, we need to start from the Lewis structure first. So Lewis structure, the first step is calculate the total valence electron for the compound. So for the compound IF3, we have 28 electron totals. So 28 we need to minus for the bonding electron 6, and then we left for 22. 22 we need to fill out the terminal atom first. So the terminal atoms total 18, so we left 4. So this 4 will be at the lone pair of the iodine. So you can see why iodine have total 10 electron is because iodine has the 3d orbital which can achieve the expanded octet. So it means that iodine can have more than 8 electron. Okay, clear? So next step, what is the electron pair arrangement? So it is A, B, 3, E, 2. So the EPA is trigonal bipyramidal. So the actual molecular shape is T-shape. Why T-shape? Because it has 2 lone pair and 3 terminal atoms, so it is T-shape. And then we straight away go for the hybridization and also molecular polarity. Okay, the hybridization orbital for the IF3 is sp3d because the EPA of the IF3 is trigonal bipyramidal, so the hybridization orbital is sp3d, and the molecular polarity is polar. It is a polar molecule because it has the lone pair. It is not the symmetrical. It is asymmetrical. So what is symmetrical? It is the basic shape with no lone pair, but it has lone pair, right? So it is not. It is a polar molecule. Clear? Okay. So for IF4 plus, we can see the valence electron is 34. Okay. So we need to be aware for the positive sign, right? Because it means that we need to lose 1 electron. So same process, we need to minus for the bonding first, and then fill up the terminal, and then add the excess in the iodine in the central atom. So we can deduce the shape is AB4E. Is also a type of the trigonal bipyramidal, which is seesaw. It is seesaw. Can you see the seesaw here? Yeah, seesaw. Yes. Okay, this is still a type of the trigonal bipyramidal, right? So the hybridization orbital is sp3, and it is also a polar molecule. Why? Just same like the previous one, because it is asymmetrical, means that it has lone pair, so the lone pair will affect the polarity. Yeah, and then be aware of the positive sign. Yeah. So move on to IF4 minus. So same like the both previous one, we need to be aware for the minus sign. So we need to plus 1 electron for them. So the total will be 36, and then same, we do the Lewis structure and minus this bonding, and then fill up all the electron at the terminal atom, and then fill up for the central atom. Be aware of the minus. Okay, so deduce the shape is AB4E2. See, this one is different from the previous 2 because it is octahedral. Okay, the electron pair arrangement is octahedral, but it is before E2, right? So the real molecular geometry is square planar. So the hybridization orbital is sp3d2. So you can look at special case why it is non-polar molecule although it has lone pair, because the lone pair can cancel each other at the bottom and at the outward. So it will become the non-polar molecule. This one is special for the this one is special for AB4E2 because the lone pair outward and bottom of the central atom can be cancelled out. Okay, move on to the B1. So the B, we need to describe the hybridization process of NF3 and draw the overlapping orbital. We need to draw the hybridization orbital for them. So as usual, we need to calculate for the total valence electron. Nitrogen is 5 and then F is 7. So total is 26. So we need to draw the skeleton first and then we can deduce the shape is tetrahedral. And then this one is AB3E. So the shape will be trigonal pyramidal. Okay, trigonal pyramidal. Okay, so the type of hybridization will be sp3 because the molecular geometry is tetrahedral. And then we move on to the hybridization process. We need to draw the orbital diagram for the central atom and also the terminal atom. So for the central atom, the ground state of N have 5 electrons at 2s and 2p. So do we need to excite anymore? No, because the 2 electron refers to the lone pair at here, and then 2p, 3 orbitals of 2p refer to the 3 bonding. Yeah, so for N ground state is already fulfill the condition, so we don't need to excite anymore because we don't need to excite for another. We don't have 2D, right? 2 don't have D, so we don't need to do that. So we just skip to the hybrid state. So it will form the sp3 because the type is sp3. So for terminal atom is simple, just ground state and then draw the orbital diagram. So this one will be the diagram for the hybridization process. So this one is N, the central atom. So we draw for the lone pair first at the sp3 orbital, and then this 3 sp3 orbital, we have 1 electron of nitrogen and it will overlap with the fluorine 2p orbital of fluorine by forming sigma bond. So that is the hybridization process, and this is the explanation. Overlapping of sp3 hybridized orbital of nitrogen with 3 2p orbitals of fluorine by forming 3 sigma bond. Okay, do you notice that there is 3 sigma bond? The sigma bond must be labeled. Okay, that's all for it. Thank you.